Welcome class 10th. Today we are going to start a new chapter, that is chapter number 12, areas related to circles. So in our earlier class 9th, we have studied that circle is a collection of all points in a plane which are at a constant distance from a fixed point. So that fixed point is called the center, and the points which are equidistant from this fixed point, these are the points which are equidistant from this fixed point, and the collection of these points in a plane is called circle, right? So if we'll join all these points, the collection of these points, okay, is called a circle. Okay, then also we have read various terms related to circle, like radius, that is the distance between the center and any point on the circle, that is radius. Okay, chord, diameter, circumference, area, right? So radius we denote by r, and we know diameter is twice of radius, and circumference of a circle means that is 2 pi r, area of a circle, that is pi r square. Okay, so this all we have read in our earlier class, that was 9th class. So here we will discuss we are going to discuss the concepts which we have read earlier, that is perimeter, that is circumference, and area of a circle, and will apply this knowledge in finding the areas of two special parts of a circle, or a circular region known as sector and segment, and then we'll move to length of arc. So let us understand what these two important parts are there. Okay, so first of all, we'll discuss what is a sector. So the portion of a circular region enclosed by two radii and the corresponding arc is called a sector. See, suppose I am having a circle. Okay, this is the center, and let me say OA and OB are two radii of the circle. Okay, and this region which I am shading, this is enclosed by these two radii and the corresponding arc. Let me write here P. So OAPB is called sector. Okay, right? And let me take a point here. So this OAPB is also a sector, and OAQB, this is also a sector. Okay, So what is the difference between these two sectors? As OAPB, which I am studying with this one, you can see this is its size is smaller than the OAQB. So this is minor sector, this is minor sector, and OAQB here, this one which I am shading with this OAQB. This is our major sector. This is our major sector. Major sector. Right. Now let us say that the corresponding arc APB is subtending an angle theta with a center O. So how to find our minor sector and major sector? So to find the area of minor sector, area of minor sector, as this is a part of a circle, so we can write theta by 360 pi r square. This is for minor sector. And please remember that if anywhere it is written sector, so it means it denotes for minor sector. Okay, and if right, okay, then area of major sector, area of major sector. So in the figure, if you'll see major, this is theta, so this angle will be what? That is 360 minus theta, and we are going to find the area of this region, that is major sector. Okay, that is major sector right here, major sector. Okay, so we can write area of major sector, that is equals to 360 minus theta by 360 pi r square. Okay, now second thing is we are having a circle. Okay, suppose this is the center O, right? Now the second important thing here that we are going to discuss, that is area of segment. So what is area of segment? That the portion or part of the circular region enclosed between a chord and the corresponding arc. So let me say AB is a chord, AB is the chord of this circle, right? So the area enclosed between this chord and this arc, this one, is called segment. Okay, and this is also our segment, right? What is the difference between these two? One is major, one is minor, right? So which I am shading with yellow, this is our major segment. This is our major segment. Okay, and this is our minor segment. Here also we have to remember that if someone has written segment, so segment means minor segment. Be sure about it, right? Now let us say, let me join the radius OA and OB, right? And here let us say the angle is theta. So you can see clearly, if you find the area of minor segment here, right, minor segment here, this one, so what we'll do, we can find it easily by finding the area of this sector. Okay, let me say this sector is OAPB and minus area of this triangle OAB, right? So area of minor sector you can give by area of sector, we are finding minor segment, area of minor segment, right? That is equals to area of sector, okay, area of sector minus area of triangle, and name of this triangle is OAB, area of triangle OAB, right? So when you solve it, you will have theta by 360 pi r square minus 1 by 2 r square sine theta. So for minor segment we have to learn this formula, theta by 360 pi r square minus 1 by 2 r square sine theta, where theta is the angle and r is the radius. Okay, then if you want to calculate area of major segment, area of major segment, then we can find it by area of circle minus area of circle minus area of minor segment, area of minor segment, means to find major segment we need to find area of circle and then we'll subtract area of minor segment from it. Okay, okay, then let us come to Okay. Now next is length of arc. Length of arc. Okay. So let us say this is a circle. O is our center. Okay. And AB is our concerned arc. So if I say APB is our arc, one is APB, that is minor arc, and one is, let me say here, Q point is there, AQB is our major arc. Okay, so APB is our minor arc, small in length, and AQB is our major arc. It is more in length. Okay. Okay, so let us say this, let us join OA and OB, and this arc is subtending theta angle at the theta. Okay, so APB is our minor arc, so we can write length of minor arc. Okay, that is theta by 360, and the circumference of the circle is 2 pi r, right? Then if this angle is theta, so this angle will be what? 360 minus theta, right? So I can write length of major arc, that is 360 minus theta by 360 2 pi r. Here please remember again, if in any question or anybody says arc, so arc means, sorry, arc, length of arc. Okay, length of arc. Then if somebody says find the length of arc, it means he is saying for minor arc. It is saying, he is saying for minor arc. Okay, right? Okay. So these formulas we have to understand, we have to remember, and we have to understand the concept also, how we are doing what. So let us start exercise 12.1. Exercise 12.1. Question number 1. It says that the radii of two circles are 19 centimeter and 9 centimeter. Let me write. First one is 19 centimeter and second radius is given 9 centimeter respectively. Find the radius of the circle which has circumference equal to the sum of the circumference of the two circles. Okay. Uh, so let us say, let the radius of required circle be capital R. Okay, so circumference of that required circle I am going to give by capital C, that is equals to circumference of the first circle, that is C1, plus circumference of the second circle is C2, right? So circumference we know, that is 2 pi, and R C1, circumference of the first circle whose radius is 19 centimeter given. Okay, so this related to this, and C2 radius also, right? So this is 2 pi r1 plus 2 pi r2. So what next, what we can do, 2 pi r, that is equals to taking 2 pi common, that is r1 plus r2. Okay, so 2 pi cancelled by 2 pi, so we will have r is equals to r1 plus r2. So capital R, that is r1 is 19 and r2 is 9, so r is 28 centimeter. So therefore what we can say, the radii of that circle, required circle, is, therefore the radius, not radii, the radius of required circle, is 28 centimeter. Okay, same like this question 2 is also there. Okay, I am coming to question number 4, which is an important question of this exercise, right? So let us take question number 4 first. So the question is, the wheels of a car are of diameter 80 centimeter. Diameter is given 80 centimeter. How many complete revolutions does each wheel make in 10 minutes? Time is given 10 minutes. Right? When the car is traveling at a speed of 66 km per hour, speed is given 66 km per hour. Okay, right? So we'll start from here. Speed is given 66 km per hour. So what is the meaning of 66 km per hour? It means in 1 hour, car is traveling 66 kilometers. Okay, so 1 hour I can write 60 minutes, right? In 60 minutes it can go 66,000 meters. So I have changed kilometer into meters and hours into minutes. So I'm going to change 80 centimeter into meters also, right? So radius will be what? 0.4. Okay, meters, right? Okay, so in 60 minutes it can go 66,000 meters. So in 1 minute it can go 66,000 by 60. Okay, and in, for how many minutes it is given in the question? It is 10 minutes. So therefore in 10 minutes it will go 66,000 multiply 10 by 60. So we can cancel out. Okay, 10 6 is 60, 6 11 ja, that is 11,000 meters. So 11,000 meter is the total distance traveled. Okay, right? Then now what we need to find, we need to find the how many complete revolutions, so therefore number of revolutions will be what? That is equals to total distance covered, by distance covered in one revolution, Okay, so that is total distance covered is how much? That is 11,000 meter that we have calculated, and distance covered in one revolution, that is given by the circumference, that is 2 pi r of the wheel. Okay, that is given by circumference of the wheel, that is circular, and a circle, as a circle, and we know circumference of a circle is 2 pi r. So here putting the values 11,000 by 2. For pi nothing is given in the question, so we can use 22 by 7. So 22 and by 7 we'll write in the numerator. Radius is given 0.4. Okay, right? Okay, so we can cancel out 11 to 22, 11 1 11, that is 0 0 0. Okay, then we can remove a point, remove this point, and we can increase 0 here. Okay, so this is 235, right? And then we can have more calculation, 1000 multiplied 35 by 8, right? So it will give us, we'll cancel it out, it will give us 4375 revolutions. Okay, right? So each wheel will make 4375 revolutions in 10 minutes. Okay,